May 2009 M1 question 8. When you look at the mark scheme for this question, you'll see two solutions, one using the equations of motion and one using velocity time graphs. My preference in these questions is always to use a velocity time graph, so I am going to use one for this solution. I'm going to start by representing the information from the question in a velocity time graph. When you do this in the exam, please make sure that you use a ruler and a pencil. The motorcyclist is travelling at speed 30 and accelerating at 0.2. Passes a police car which is at rest, and 5 seconds later the police car sets off in pursuit of the motorcyclist, accelerating at 1. So that's my police car and my acceleration is 1. I am going to mark on the diagram this point, time t, and say that it is here that the police car draws level with the motorcyclist. And what do I have to know about that? Well, at t they have to have covered the same distance. Velocity time graph, the area under the curve is the distance travelled, so I'm going to work out the two areas. I'm going to start with the motorcyclist, and this is a trapezium, and I need to work out the height of the right hand side, so I need to work out this height, and that's going to be the velocity at time t. So velocity equals u plus at, and in this case that is 30 plus 0.2 t. So the area under this curve for a trapezium is half the sum of the parallel sides, so that's 30 plus 0.2 t times the distance between them, which is t. So that's a half upon 60 plus 0.2 t. If I expand out those brackets, I'm going to get 30t plus 0.1 t squared as the distance for the motorcyclist. I'm going to consider the police car now. That is a triangle, and the base of the triangle is going to be t minus 5. To work out the area of the triangle, I need to know the height, and that is the velocity. So again, I'm going to use velocity equals u plus at. U is 0, acceleration is 1, and t is t minus 5. So the height is t minus 5. Area of a triangle is half the base times the height. So that's a half upon t squared minus 10t plus 25. And that is the distance that the police car has travelled. To finish the question, I need to equate my two formulas and then solve. So a half brackets t squared minus 10t plus 25 has to equal 30t plus 0.12 squared. So t squared minus 10t plus 25 has to equal 60t plus 0.2 t squared. If I bring everything over to the left hand side, I am going to have 0.8 t squared minus 70t plus 25 equal to 0. I'm going to use the quadratic formula, so t equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. And from my calculator I get two answers, 87.1 or 0.359. Well, that's impossible because we have to work with t minus 5, and that would give us a negative time. So the answer to the question is that t is 87.1 seconds. If you look at the mark scheme, you will see an alternative solution using the equations of motion only.